Hi, this is Sonia Doucette. In this video, I'll show you how to calculate the formula mass and molar mass of a compound. So this problem says to calculate the formula mass and molar mass of carbon monoxide, which is a molecular compound with covalent bonds, and ammonia sulfate, which is an ionic compound with ionic bonds. So these terms, formula mass and molar mass, are calculated in the same way, even though they mean different things. So the formula mass is also known as the molecular mass or molecular weight, and it's defined as the average mass of a molecule or formula unit if you're dealing with ionic compounds. And it's expressed in units of AMU, or atomic mass units. And like I said, the molar mass is calculated in the same way, although it has a different definition. So the molar mass of a compound is the mass in grams of 1 mole of a compound's molecules, or formula units. So the units for molar mass are going to be in grams per mole. So we have atomic mass units for formula mass and grams per mole for molar mass. So let's calculate these for both of these molecules shown here. So carbon monoxide, which is a molecule, so it's covalently bonded carbon and oxygen. And what you do is you look up the atomic masses for both carbon and oxygen separately in the periodic table. And the atomic mass of carbon is 12.01 AMU. So you'll find that when you look it up in the periodic table. And then you add the atomic mass of oxygen, which is 16.00 AMU according to the periodic table. And when you add the two together, what you get is 28.01 AMU. So this would be the formula mass for carbon monoxide. You could also say that you found the molar mass of carbon in the periodic table to be 12.01 grams per mole, and add that to 16.00 grams per mole for the molar mass of oxygen. Add the two together and you'd have 28.01 grams per mole. So notice you have the same exact number here, 28.01, but if you're talking about formula mass, you report units in atomic mass units. And if you're talking about molar mass, you report your units as grams per mole. So carbon monoxide, CO, that was a pretty easy molecule. So now let's look at this larger molecule, ammonia sulfate, for this next part. So ammonia sulfate is a formula unit for an ionic compound that contains 2 polyatomic ions. And you should recognize those as ammonia and sulfate. So what we want to do here is look up the atomic mass for each of the elements in this ionic compound and then multiply the atomic mass for each by the subscript in the formula. So if you look at this compound, ammonia sulfate, you can see, so let's rewrite it here. We have ammonia sulfate. You can see that there are 2 nitrogens, and then you have to multiply the 2 times the 4 to figure out the number of hydrogens. So you have 8 hydrogens, you have 1 sulfur, and then you have 4 oxygens. So what you do is you multiply the atomic mass for each of those elements by those numbers to get the formula mass or the molar mass. So let's speak in terms of formula mass. So you say 2 times the atomic mass of nitrogen. When you look that up in the periodic table, you get 14.01. add that to 8 times the atomic mass of hydrogen, which is 1.008 AMU when you look that up in the periodic table. And then you add that to 1 times the atomic mass for sulfur, which is 32.06 when you look that up. And then finally you have 4 times the atomic mass for oxygen, which is going to be 16.00. So when you do the math there, you're going to get 132.144 or something like that in your calculator. What you want to do now is round that to 4 significant figures, because each of these atomic masses that you got from the periodic table have 4 significant figures each. So your final answer here will be 132.1 AMU if we're talking about the formula mass, and you can also express that in grams per mole if we're talking about the molar mass. So that's it.